In this lecture, we will study the types of RAM memory. Now here we can see that read write memory or random access memory are divided into two types. One is a static RAM and another one is a dynamic RAM. So what is static RAM? Static RAM is also called as SRAM. It consists of circuits that are capable of retaining their state as long as the power is applied. Means what? If the power is there, then it will hold the data. If any interruptions in the power, it lost the data. Now, these are also called as volatile memories. Now, access time of static RAMs are in the range of few nanosecond. Means what? These are very fast memory. And the cost is also high. Now, we will see the circuit diagram of RAM cell. Now, this is the RAM cell. Now here the two transistor inverters are cross connected to implement the basic flip-flop. Now this cell is nothing but what we studied. Now it is nothing but a flip-flop to hold the binary value. Now here you can see the two transistors. These transistors are used as a switches. Now these transistor connected to the word line, and here it is connected to the bit lines. Now if the word line is equal to 0 means what? Address is not selected for this word, so not given for this word line, so then it is 0, thereby what? Transistors are off and acts like an open switch. Now whatever the information is at point X and at point Y are there, it will retain that information. Now how the processor will read and write the data from the static RAM means, now here it will place the a word line become one. How it become one means, when it gives the address, with that address that word line will be enabled. So that is nothing but word line is one. If the word line is one, then the transistor is on and acts like a closed switch. Now it is acting like a closed switch, and this X is connected to this bit line and Y is connected to the bit bar line. Now, whatever the information is available at X and Y will be placed on these bit lines. Like this, processor will read the data information. Now, how the processor write the data means what? The bit line, word line is equal to 1. Now, it will keep the data on the data bus. By giving the address, it will word line will be selected, and by placing the data, that data will be available on these bit lines. So sense write circuits will monitor the B and B dash. Now here if the B value is equal to 1 and B dash value is 0, now these are nothing, B dash is a complement or always complement of B. If B value is 1, then how it will write this data means, when the word line is equal to 1, these transistors are acting like a closed switch. Now whatever the data is there, that is forced are placed into this latch. Now this become 1 and this become 0. Like this, the processor will write the data. Now the same circuit can be implemented by using the CMOS transistor. Now here we are using 6 CMOS transistor to design the SRAM. Now operation is almost same, like it is same as this only. Now instead of showing the, now here this latch is designed by using the 4 CMOS transistor. Now total it requires 6 CMOS to design the SRAM. Now coming to the DRAM, SRAMs are very fast and high cost because of their cell require several transistors. Now less expensive RAMs can be implemented if simpler cells are used. Now that is nothing but a DRAM. Now if you see the circuit of DRAM, it is having one transistor connected, one capacitor. Now here the information is stored in the form of charge across the capacitor. Now uh, here the because the capacitor is having some internal resistance and always it will try to discharge, because of that it will lose the information for longer, it can't hold the information for the longer time. For that it needs the refreshing circuits. So periodically refreshing circuits means what? So for intervals of time, we need to charge the capacitor. That we will I will explain later. Now how, what happens if the word line is equal to zero? Word line is equal to zero, transistor is off, and it acts like an open switch, and whatever the charge is across the capacitor, it will retain as it is. Now with respect to time, it will discharge. That will be different again, that will be discussed later. Now if the word line is equal to 1, then in the case of read operation, in the case of read operation, now this transistor is acting like a closed switch, and this capacitor is connected to the bit line. Now whatever the charge is across the capacitor is available at the bit line. Now if the capacitor is charged fully, then it is logic 1. If the capacitor is not charged, then that is considered as a logic 0. Now here logic 1 and logic zeros are, here we are taking the one threshold value. Means what? Across the capacitor charge, we are taking one point that is called as a threshold point. Threshold point. If the capacitor charge is greater than the threshold charge, then that will be considered as a logic 1. If the capacitor across, if the charge across the capacitor is less than the threshold point, then that will be considered as a logic 0. Now, like this, if this point is, now the word line is equal to 1, if this point is connected to this C is connected to the bit line. Now, depending upon the charge availability, it will read the data as a logic 1 or logic 0. Now, how the capacitor is writing means what? Now, for example, on the bit line, 1 is available, data bit 1 is available. So because the word line is 1, then the transistor is acting like a closed switch, and this 1 will be applied to the capacitor, and capacitor charges to the maximum. Similarly, if the 0 value is available, capacitor will not charge, and that will be considered as a 0. Now, already we have discussed that because of the capacitor internal resistance, it will try to, the capacitor will try to discharge. So if the charge across the capacitor is reducing below the threshold point, that information 1 become a 0. So that should not happen. Means what? We need to charge the capacitor periodically. That is called the refreshing. That is called as a refreshing. For a time interval, we need to refresh the capacitor. That can be done by the dummy read operation. Now, if the capacitor processor is reading, then how the processor is reading? Just now we have discussed. Now, if the processor is not reading for particular periodically, needed to be dummy read operation, so that the capacitor should be charged maximum. Now, all the cells within the memory uh, are connected to the word line. Now all the cells are activated. Now activated means what? Word lines are 1, thereby what? Transistor acts like a short circuit, and whatever the charge is available on the capacitor will be applied onto the bit line. Now if the charge is 1 means what? So capacitor will charge it to the maximum. If the capacitor across, now if the capacitor is connected to the bit line means what? If the charge is greater than the threshold, means that is considered as a logic 1, and the capacitors are charged to the maximum. If the charge across the capacitor is less than the threshold point, then that will be considered as a logic 0, and capacitors are not charged. Now, like this, for the dummy read operation, it will check the capacitor charge, and if it is greater than the threshold, it will, capacitors will be charged to the maximum to retain the logic 1. Now, this is called the refreshing the capacitors. Now here there are differences between SRAM and DRAM. Now SRAM stores the information with the help of transistor. Already we have seen that in 6 transistors are used in the SRAM, and the capacitors are not used, which means a refresh is not needed. So in a SRAM, we are not using the capacitor. That's why refreshing circuits are not used. And these are high-speed devices. SRAMs are high-speed and expensive and low-density devices. Low density means what? For the given area, how many number of cells are inserted, or for a given area, how many number of bits are stored. That is nothing but a density. So low density means what? Because it is required 6 transistor, it occupies more space for each cell, thereby what number of bits are stored less compared to the DRAM. So that's why here we are calling it as a low density devices. And because these are fast, that's why we are using these to design the cache memories. Now coming to the DRAM, DRAM stores the data using the capacitor. So capacitors are used, that's why refreshed, needed to be refreshed periodically to restore the content. Now these are the uh, low speed memory circuits. So compared to the SRAM, speed is less and inexpensive, and high density devices because only one transistor and one capacitor is used. That's why here, given area, more number of cells are inserted, thereby more number of data is stored. And because the density, high density, we are using these cells to design the main memories. So we are using these cells to design the main memories. Now here I have given the differences again, and from these differences you can write the advantages and disadvantages of SRAM and DRAM. We will study the asynchronous and synchronous DRAM in the next class.